So this video is on homework chapter 2, homework number 4, which is 2-6 through 2-11. So on this first section here, we are supposed to solve these quadratics, but they want us to use any method besides quadratic formula. Now on letter A here, we have y squared minus 6y equals 0. What I would recommend in a case like this is when you have y squared and y and you don't have a constant, is you can factor out a y from both terms. Let me write that a little better. Get this a little bigger. So you can factor out a y from both terms. And then you're going to end up with y equals 0 and y equals 6. Those are your answers. On letter B. Now on letter B, it looks like it does have a constant here, but when I subtract 7 from both sides, I'm going to end up getting 5n squared plus 5, sorry, not 5n squared, n squared plus 5n equals 0, okay? Now I have no constant. I have an n squared and an n, and I can again factor the n out. And I get n times n plus 5 equals 0. And well, I'm going to set each of these to 0. So n equals 0 is one answer. And what makes this 0? Negative 5. And those are your two answers. Now on letter C, now on this one, you do have a number in front, but you'll notice here we have a 3 and a 3. So when I subtract 3 here and subtract 3 here, they're going to cancel out. So I'm going to get 2t squared minus 14t equals 0. So this is going to be the same format as the last two. Now, in the last two, I just factored out a t. In this case, I can factor out a 2 from each of the numbers and a t. So this is going to be 2t times t minus 7 equals 0. And again, I'm going to set this equal to 0. I'm trying to figure out what makes 2t 0, and that's going to be t equals 0. And what makes t minus 7 0, that's going to be t equals 7. And those are your two answers. Now on letter D, the first thing I'm going to do is I'm going to add 4 to both sides. So I'm going to get 1/3 x squared plus 3x. And when I add 4 to both sides, I get equals 0. Now, I can this is going to be like all the other problems, and I can factor a 1/3, but that might give some people some difficulty. So what I'm going to do is I'm going to multiply everything by 3. I'm going to fraction bust, okay? So I'm going to multiply this by 3. I'm going to multiply this by 3, and I'm going to multiply this by 3. And when I do, these 3's are going to cancel out here, and I'm going to be, so those are going to be gone, and I'm going to be left with x squared plus 9x equal 0, and that might be a little easier for us to deal with. So now you can see again, I've got no constant, and I've got x in both of these, so I can factor out my x, and I get x times x plus 9 equals 0, and I get x equals 0 for this, and for the parenthesis, I get x equal negative 9. And those are our two answers. Now on E, they're asking us, 0 is a solution to each of the above equations. What do all the above equations have in common that causes them to have a 0 as a solution? So the reason all of these have a 0 as a solution is because once I got them cleaned up, none of them had a constant term. Okay, so here at first it looked like we had a constant, but when I got my numbers on the same side, they canceled out. So none of these did I end up having a constant. Okay, all of them were just my n squared and my n, or my y squared and my y, no constant. Okay, so each problem had no constant term. So we were able, get that so you can see that. So we were able to factor out a variable from each term, and that's what gave us our 0. Okay, the one that was factored out, that was one that gave us our 0. Okay, so let's look at the next problem. So for each of these ones, we're trying to be asked to find the vertex for each of the parabolas by averaging the x-intercepts, because just a little visual, quick visual, and I'll erase this. If I have a parabola, let's get a different color here. Okay, so let's say that's my xy axis and I have a parabola. And let's say this is an x-intercept and this is an x-intercept. Halfway in between any of the x-intercepts is going to be the line of symmetry, the line that I could cut the parabola in half and it's going to be the same on both sides. And on that line of symmetry is your vertex. So if you take your two x-intercepts and average them, add them up and divide by 2, it's going to give you the x-coordinate of your vertex. And then once you know the x-coordinate, you can plug that into the equation to find the y that goes with it. Okay? So for this one, when I'm finding x-intercepts, your y is 0. So I'm going to go 0 is equal to, oops, hold on. Okay, sorry, I ended up pushing a button by mistake. So 0 is equal to x minus 3, x minus 11. And so I'm going to solve, okay, use the zero product property. So I'm going to end up getting x equal 3, x equal 11. Those are my x-intercepts for a parabola. So now I'm going to average them. I'm going to take 3 plus 11, I'm going to divide it by 2. So that's 14 divided by 2, which is 7. So my vertex is going to be 7 comma something. Now to find the something, I'm going to be putting 7 back into the equation for my x. So I'm going to go parenthesis 7 minus 3 parenthesis 7 minus 11, and I end up with negative 16. So this is our equation. I mean our vertex. They want an equation though. So for the equation, let me just write it here. The graphing form of a parabola, this is something you should have learned last year, but I'll remind us, y equal a times x minus h squared plus k. And h comma k is your vertex. Your a is your stretch. So in this case, since both of these are just x, there's no stretch besides 1. So my equation, so this is my vertex, but my equation is going to be, let me get my pen back, undo my things. Okay, so my equation is going to be y equal, a little bigger here and focus. So y equal x minus 7 squared minus 16. So that is going to be our answer. Now I'm going to do the same thing for this one. Okay. So again, I'm going to set this to 0. So this is going to be 0 equal x plus 2, x minus 6, because when you're trying to find the x-intercept, set your y to 0. So this is going to be a negative 2 and a positive 6. So I'm going to average those, negative 2 plus 6 over 2. 4 divided by 2 is 2. So I'm going to get 2 comma something. So I'm going to put that into my calculator. Okay. Let me get this a little easier to see maybe. So 2 plus 2 times 2 minus 6. So I'm just plugging it into the x's right here. And I end up getting a negative 16. Happen to be a negative 16 again. It's not always the case. So now my equation is, again, y equal x minus 2 squared minus 16. So again, this is my vertex. This is my equation in graphing form. Now, C is different than this. So C, if I can make it look like this factoring and solve that way, that would probably be the easiest. So first off, I'm going to have it set equal to 0. And then I'm going to ask myself, what multiplies to 40 and adds to negative 14? So that's going to be a negative 4 and a negative 10. Okay, that multiplies to a negative 40. I'm sorry, to a positive 40 and adds to negative 14. So I'm going to get a 4 and a 10. So I'm going to go 4 plus 10 divided by 2, again averaging them. So that's going to be 14 over 2 or 7. So I'm going to get 7 comma something. So when I put this in my calculator, I'm going to go parentheses 7 minus 4, parentheses 7 minus 10, and I end up getting a negative 9. So that's going to be my vertex. Your graphing form is going to be y equal the quantity x minus 7 squared minus 9. So that's going to be our equation. Now the next one is in the form we want. Okay, this is the form. So my vertex is going to be 2, negative 1 in this form. Let's say you didn't recognize that. Then if you were to put 0 here to find your x-intercept, you would have ended up with this. When you have something like this, you're going to add 1 to both sides. Don't FOIL this out. Add 1, and then you're going to take the square root. So I'm going to add 1 to both sides. So I get x minus 2 squared. I'm going to take the square root. So when I take the square root of 1, I get a plus minus 1 equal x minus 2. I'm going to add 2, so I get 2 plus or minus 1 equal x. So I'm going to get two answers, 3 when I do 2 plus 1, and 1 when I do 2 minus 1. And again, if I average my two x-intercepts, 3 plus 1 over 2, I get 4 over 2, which is 2. And then if I plug this into the equation, I get 2 minus 1 squared minus 1, which gives me, sorry, I did the wrong number, 2 minus 2, okay, there's a 2 there, squared minus 1, and I end up getting a negative 1. So you see, this was my vertex, and this is in the nice graphing form that they want. So they actually gave it to you in the proper form. This is the vertex. Okay, next set of problems. So on these ones, we're going to be dealing with our triangles. Now, 15 degrees is not a special triangle. And it says here that for part D, we're going to approximate it and give radical form. So for the rest of them, we probably are going to be getting a decimal. So when I'm doing this one here, I'm going to be doing trig, and I need to remember SOHCAHTOA. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in this case, I'm dealing with my 15 degrees. You always want to be paying attention to where you're coming from. And this is going to be opposite. And the one across from your 90 degrees is always your hypotenuse, every single time. Okay, it's not my adjacent. This would have been adjacent. The one across your 90 is always your hypotenuse. So since I have opposite and hypotenuse, that's going to be sine. So let me kind of get a little more space here. So this is going to be sine of 15 degrees equals opposite, which is x, over adjacent, which is 20. If I was to put this over 1 and cross multiply, I'm going to get 20 times sine of 15 degrees equals x. And now I'm going to put this in my calculator, but you want to make sure your calculator is in degrees, not radians. Okay, we're dealing with degrees right now. And so I'm going to go 20 sine 15, and I end up with 5.176. So if I'm going to do two numbers after the decimal, the 6 is going to push the 7 up to an 8. So I'm going to do 5.18. So this is going to be 5.18 is equal to x. On letter B, this one's also 15 degrees. I'm coming from this side. This is opposite. This one would have been my hypotenuse across here. So this one is my adjacent. And so again, SOHCAHTOA. This is going to be opposite and adjacent, which is tangent. So I'm going to be doing tangent. So I'm going to do tangent of 15 degrees equals opposite, which is 5, over adjacent, which is x. So I'm going to put this over 1 and I'm going to cross multiply. So I'm going to end up getting x times tangent of 15 degrees. And when I multiply this side, I get 5. Now I'm solving for x. So I want to divide by the tangent of 15. So I'm going to divide this side by tangent of 15 and this side by tangent of 15. So I'm going to get x is equal to 5 over tangent of 15 degrees. And I'm going to put that into my calculator. Okay. So I'm going to go 5 divided by tangent of 15 degrees. And I'm going to get 18.66. So I get 18.66 as my answer. Okay. So letter C. This time I'm trying to find my angle. Okay, so from this angle, this would have been opposite, so I don't have opposite. This one's across from my 90, so this is my hypotenuse. And this one is adjacent. So again, if I'm thinking of SOHCAHTOA, I have adjacent and hypotenuse, I have cosine. Now, I'm going to take cosine of, I don't know the angle, that theta, that's what I'm going to try to find, is equal to adjacent over hypotenuse. Now, when you're trying to solve for the cosine, you're going to do, for the angle, you're going to use cosine inverse in this case. So I'm going to go cosine inverse of 10 over 11 equals. So on my calculator, the cosine inverse is the one on top of the cosine, okay? So I have to do second cosine, and then I'm going to do 10 over 11, again, making sure my calculator is in degrees, and I get 24 points, let's say 62. I'm going to push that up to a 62 degrees, so 24.62 degrees. Now on letter D is one that we used to know way back in integrated 1 before we learned all this trig. So what you want to pay attention to is this happens to be a right triangle where we know two sides and we need to find the third. So we're going to do Pythagorean theorem, a squared plus b squared equals c squared. C squared is always your hypotenuse, always, always, always. What I like to do is I like to look at my picture and circle my hypotenuse so I always pay attention. A lot of times people automatically try to put their x here. In this case, it happens to be the right spot because it's your hypotenuse, but it's not always. So I like to circle it to focus myself. 6 squared plus 12 squared equals x squared. Okay, so I'm going to take 6 squared plus 12 squared, and I end up getting 180. So I get 180 is equal to x squared. Now, normally I would take a plus and a minus when I take the square root, but it's a triangle, so I'm not going to have a negative side, so I'm just going to keep my positive. But on D, they want us to do two things. They want it in radical form, and I want it in simplest radical form, and then they want it as a decimal. So we'll do the decimal here in a second, but in order to simplify this, you want to ask yourself, is there any perfect square that's in this? Okay. If you can't think of a perfect square that's in this, this is a way you can go about doing it. Okay, let me just grab a different color. Okay. So you can break 180 down, prime factor. So I'm looking at this going, well, I know it's a 10 and an 18. Maybe you know it's a 2 and a 90. Okay, start with whatever two numbers you know multiply to get you 180. Keep breaking it down so you get primes. So this is going to be 2 and 5. Once I get primes, I circle them so I know I can't break them down anymore. 18, let's say I think of it as a 2 and a 9. Some of us might say 6 and 3. Doesn't matter, keep breaking it down. My 9 I can break down to a 3 and a 3. Now, if you have a pair, that means that that was a perfect square. So do you see how I have two 2's? Because I really had a 4, and the square root of 4 is 2, so a 2 would come out. And then I had two 3's, which is a 9, and the square root of 9 is 3, so a 3 can come out. So when you have pairs, that's going to come out of your radical. Now, again, I circled everything that could not be reduced. So my 2's came out, my 3's came out. I'm left with my 5. That's going to go underneath my radical. So this is going to be 6 root 5. That would be your simplest radical form. Now, they also wanted a decimal. Now, if I'm doing the decimal, I would just do it as the square root of 180. Okay, that's fine, doesn't matter. Square root of 180. And you see I get 13.42. If I did 6 times square root of 5, you see I get the same answer. So as a decimal, this is 13.42. Okay, so they wanted two answers for that. And then the last set. So on this last two problems here, this one is asking us to find the point of intersection of these two lines. But they want us to do it without graphing, and so we need to explain how to. So when you have two lines and they're both in y equal form, we call it equal values. You can set the two equations equal. So I'm going to take 18x minus 30 equals negative 22x plus 50, and I'm going to solve for x, for the x coordinate of my point of intersection. So looking at this, I'm probably going to want to add my 22x. That's going to probably be the nicer thing to do. And so I'm going to get 40x minus 30 is equal to 50. I'm going to add 30 to both sides. So when I do that, I get 80. I'm going to divide both sides by 40, and I get 2. So now I'm going to have 2 comma something. That's going to be the point of intersection. So at this point, I can plug it into either equation because it should be making both of them the same, because this is where both of them are the same at the same time. So let's say I do it into the 18. So I'm going to go 18 times 2 minus 30. That's a 36 minus 30, so I get a 6. And this is my point of intersection. And the last problem, this is really kind of review from integrated 1. Did a little bit in 2, but probably more in 1. When you have the same base, the exponents have to be the same. So just kind of as a quick example, if I had 10 to the x, let me get my pen back, sorry. If I have 10 to the x is equal to 10 to the 5th, I think a lot of us could tell me, oh, x has to be 5. And if I had 10 to the x plus 2 is equal to 10 to the 5th, I think a lot of us could go, oh, since this is a 5, this would have to be a 3, so that's a 5. Basically what's true is when the bases are the same, the powers have to equal each other. So that's what I'm going to do here. I'm going to equal my powers. So since I have 10 on both sides to a power, my 3x has to be the same as my 8 minus x minus 8. I'm going to minus x from both sides, so I get 2x is equal to negative 8. I'm going to divide by 2, so I get x is equal to negative 4. And that's my answer. Now, if I want to check my answer here, if I was to take 10 raised to the 3 times, negative 4, you see I get this answer. This E means scientific notation. It means times 10 to the negative 12th. And then let me take 10 raised to the power negative 4 minus 8. And you see I got the same answer. So that's your answer. Hopefully this is helpful.